Hello ladies and gentlemen, today we're going to go over E-fields or electric fields. We're going to go over how to draw them, what they mean, the equation, and what we can do with this information. Now to start us off, E-fields or electric fields is a lot like gravitational fields. So what I drew on the board is a gravitational field, and if this is the Earth, those lines represent what will happen if a small object is dropped near the surface of the Earth. Well, we of course know that if you do drop anything from the surface of the Earth, the gravitational field or the gravitational field strength will pull it down. And E-fields are a lot like that, but instead of using the Earth, we use charges. Now the equation for the E-field is E for E-field is equal to the force between the two charges divided by the charge itself. You might see this rewritten as F is equal to EQ, but both are acceptable. Now, how do we draw E-fields? In order to draw E-fields, what you must first start off with is a charge. I'm going to start off with the two types of charges, the negative charge and the positive charge. Here I have two charges. The positive charge is represented by the blue plus sign, and the negative charge is represented by the negative red sign. When you draw E-fields, you must always start off with a circle, which represents the charge, and the field itself is represented by the arrows. So let's start off with the positive charge. In order to draw a positive E-field, the arrows must go out of the charge itself. Okay? Now let's compare that to a negative charge. The negative charge is designated by the arrowheads pointing directly in towards the charge. Now, here are the two examples of charges and what they are, or how they are represented as. Now, what if we have two of the same charges? How can we tell them apart? How can we tell which one has a stronger E-field? There are two ways of going about this. In order to show how the two are represented, I'm going to draw two more charges. And in these two charges, I will draw the two different varying degrees or the magnitudes of how the charges can look. Now, if we compare this charge to this charge, what do you notice?
Less line!
Right, so there are a lot less lines. So what that means is that the E-field is weaker. So if we want to draw a strong E-field, we have to draw more lines. If we take a look at this charge versus this charge, we can clearly see that this E-field is a lot stronger than this E-field because there are more lines. Now when you are drawing these E-fields, it's very important to know that you never ever cross the field lines. It's kind of like in Ghostbusters, you never cross streams. Or in other aspects of your life, you never cross streams, or you never cross the lines. So same with E-fields. Okay? The more lines you have, the stronger the E-field is. Now, we can also draw multiple charges along the same plane. And when we do that, we can see how different charges interact. So here we have a positive and a negative charge, and they're close to each other. How will these charges interact? Well, if we follow the same rules, where the positive charge has arrows coming out of it and the negative charge has arrows going into it, we can visually represent what an E-field would look like if there are two charges that are unlike. Now, from this drawing, we can see that the arrowheads come out of the positive charge and the arrowheads go into the negative charge. Now, I did as an extra example by making the E-field of the negative charge a lot stronger, and I did that by drawing extra lines. Now, it's also important that when you draw these E-field lines, you go all the way around the charge 360-wise. Now, what if we had two of the same charges along the same field? Now, if we have two charges, two like charges along the same field, we see that the field lines actually repel away from each other. And they repel away from each other because there are two same charges. It's kind of like when you play with magnets and you have one north end and you have another north end, you try to stick them together, it doesn't work out because they repel. You might hear that in life, unlike charges or unlike people seem to attract. Well, it's kind of like that, but like charges don't attract. Now, if you're thinking to yourself, Mr. Lee, did I ever feel a E-field before in my life? Well, how about this? Next time you're next to a old school TV screen, or maybe even the TV screen that you have, try putting your hands really close to it, like this.
Stop it.
And see what happens. Now, let's say that this is my TV screen, and we're shooting the movie The Poltergeist. If you haven't seen it, it's a very famous scene, or like the ring where the girl falls out of the screen.
Oh my gosh, that's T.
But in this one, I get close to the TV screen, and I actually start to feel the E-field line. You can actually feel it on your hand. It's kind of like when you play with the Van de Graaff generator. All right, with the Van de Graaff generator, before you even touch the generator, as soon you get closer and you get closer and you click closer, you actually start to feel the E-field on your hands. So now that you know how to draw E-fields and how to draw multiple E-fields in a single plane, let's get down to how we even came up with this concept of drawing arrows. Now, in order to do this, we need to have this idea of a point charge or a positive test charge. Now, this is just a positive charge that you can put throughout any field, and it'll tell you the strength, the magnitude of the E-field, and more importantly, it'll tell you the direction of the field itself. So for this, I'm going to represent the test charge, or the positive test charge, as this rubber black stopper that we see right here. Now, here we have a positive charge, and here we have a positive test charge. If I were to put this positive test charge right there, what would it feel? So we have two positive charges, and we know that positives don't like to be next to each other. So what this positive charge is going to do to this charge is push it towards the right, like so. Now, if we bring it closer to the charge, we know that two positive things really don't want to be next to each other, and so it'll produce a force that is greater towards the rightward direction, like that. And the further out we go, the influence that this positive charge has on this positive test charge becomes less and less and less strong. So if I put it here, it'll be a smaller vector. Now, if we move this positive test charge all around this, this positive charge, we will get what we end up with the E field itself. So let's say I put this positive test charge right here. We get a force that pushes the charge to up and to the right. If I put the positive test charge right above the positive charge, this positive charge will push this charge straight up. If I put it here, it's going to go up and to the left. Here, it's going to push it to the left. Here, down and left. Here, down. Here, down and to the right. So you can see that when I place this positive test charge all around this positive charge, it's going to have a effect or a push. And that push, we can draw it as the E field. So it's just a bunch of vectors added up together to give us this image. Now, the same concept works with a negative charge. Now, here we have a negative charge and a positive test charge. We know that the positive test charge and the negative charge want to be with each other. They're attracted to each other. And so if I put this positive test charge to the right of this negative charge, this negative charge is going to pull this positive charge to the left. It's going to look like that. And then we can do the same process and go all throughout the negative charge to see what the E field will look like. And you can see that if you place this positive test charge all around this negative charge, we get the image of a negative E field that is produced by a negative charge, with the arrows going in towards the negative charge. And that is all due to this positive test charge. So that about concludes it. Let's wrap it up. In order to draw E-field lines, you need to know three things. You need to know one, you need to know the charge. Two, the magnitude of the charge. If it's a strong field, you need to draw more lines. Three, if it's a positive charge, the arrows come out of the charge. And if it's a negative charge, the arrows go in the charge. Four, if there are multiple charges, make sure you don't cross the field lines. And last but not least, make sure you draw your arrows all the way around the charge itself. Thank you.